In this video, you'll see what happened when I attempted to build the world's largest rocket-powered RC plane, a gigantic balsa wood glider fitted with a powerful solid fuel engine, originally intended for large model rockets that can fly to thousands of feet. Now this might seem like a strange concept to strap a rocket to a glider, but this project was actually inspired by one of these, a small free flight glider powered by a long burn rocket motor, originally made by a company called JetX. These tiny rocket planes were the closest thing you could get to flying a homemade jet, back in the 1950s. So this is what we wanted to supersize. The plan was 1. Design and build an aircraft with a wingspan greater than 8 feet, which is the current record for a rocket-powered model aeroplane. And then 2, launch this glider by hand before firing a rocket engine remotely to extend its flight time, hopefully gaining altitude so as to float back down to Earth for a gentle landing. The first problem was to decide on the configuration of glider we were to build. So first I put together a few balsa wood prototypes inspired by original JetX models to see how wing shape and tail design might affect flying characteristics. Next, I could add small JetX-style rocket motors to see how these gliders would fly under power.
Probably the simplest rocket plane I'll ever make.
Quickly, I made my first discovery that I shouldn't have used hot glue to attach the wings.
Melted the wings off.
I assembled a subsequent prototype with super glue, and this time I made a wing with a proper undercamber airfoil shape by wetting a thin balsa wood sheet before bending it over a former. Once dry, the wood retained its curved shape. Now I could design and 3D print a small rocket engine mount, which would make the reloading of rocket engines more practical. Now for a few test glides to check if the balance was correct. If it was nose heavy, the plane would nosedive, and if it was tail heavy, it would backflip.
Ooh.
Very nice.
I could adjust the plane using clay until I got the balance just right, where the centre of gravity was aligned with the centre of lift. We now needed to see if the plane would fly as a powered aircraft.
Safety glasses on. Safety glove. No, it's the wrong one. It's the wrong side. It's the wrong hand. 3, 2, 1.
On the first flight, I found we needed to trim out the aircraft to be slightly more tail heavy, so it would be able to fly around in circles. The second flight was a little better.
3, 2, 1, now. Oh my goodness! Oh, it nearly did it!
The third time, we managed to get a much longer flight.
1, now. Look at that! That's working beautifully. Very, very nice. Oh, it's doing aerobatics and everything. Woo! Oh, it's going into the other field. Oh dear. Hope that didn't take out a sheep or anything.
Clearly, we had discovered that we'd want radio control for our supersized rocket glider.
Right, we've learned quite a lot from that prototype. Now what we need to do is go back to the workshop and figure out how to scale it up to make it giant sized.
The main problem with building a large model aeroplane is how to make it light enough but strong enough to fly. For this reason, it is very important to choose the right materials for the job. I decided to base the wing of my plane around some very long carbon fibre tubes, which, when connected together, would form a 19-foot wing, which would be absolutely enormous. This wingspan would more than double the size of the largest rocket glider I'd found while researching this project, which had an 8-foot wingspan. This aeroplane is going to be the largest RC plane I've ever built. It's going to have loads of wing area, loads of lift, and it's going to be very lightweight. To form the shape of the wing, I decided on using light ply and balsa wood to make a simple, traditional wing structure. This would end up being much lighter than using foam board. I laser cut a bunch of wing ribs, which had lots of undercamber, and this would help the plane to fly very efficiently with lots of lift at low speeds. The ribs were designed to slide along before being carefully aligned at set intervals. Now they could be glued in place with quick setting CA superglue, not hot glue.
You should name it the Albatross.
Why?
Because they have a big wingspan.
We've named it
The albatross.
It was all looking quite good, but after taking the wing skeleton off the building board, Emma and I were a little concerned about the flexibility of this design. Although at a smaller scale, this type of wing would be quite rigid, scaling it up meant we probably should have used more diagonal pieces to stiffen it all up.
Just discovered we had too many wing ribs, so I've removed one.
It's the problem with winging it.
Finally, we had the entire wing structure complete, and it was looking absolutely ridiculous.
It's big.
Hopefully, adding the skin would improve the rigidity, and this was the next step, to completely cover every side of the 4 wing panels with a lightweight covering material called Orocover. This is applied using a small iron to stick it to the wooden structure. This is a super time-consuming process, but after a couple of days getting the covering just right, I finally had each of the sections finished. Now the carbon spars could be permanently joined together by carefully inserting thinner diameter tubes, and the special polyhedral wingtips were correctly angled using some 3D printed components. Finally, after about a week of work, the massive wing was complete and feeling pretty strong. The tail panels took into account what I'd found from building the main wing to make the whole thing far more rigid. These 2 tail surfaces were arranged in a V-tail configuration, just like the small prototype model, which would stabilize the plane just like a conventional tail, but with 2/3 of the weight. The panels were rather optimistically joined together using 2 small 3D printed parts, which would definitely not cause any issues later on. Now for the fuselage, which needed to hold any electronics and batteries we might end up using. Everything was coming together for the very first test flight.
Ta-da! Out at last. Right, let's go and see if it flies. The wind is so powerful for this super lightweight, very lifty plane. Right, now we just need to get this into the field. Right, so we've already discovered that a few things are not as strong as we want it to be, but this test is all going to be about just seeing whether the thing actually flies, how sensitive it is to the wind as well, because it's getting blown over even right now, and then, yes, what we can improve really. Oh, and getting the balance correct, that's the main thing. But yeah, I think what we'll start doing is just sort of like feeling the lift, so to speak, with the oncoming wind. The wind's coming this way, and then we can start throwing it. I'm really nervous about it, actually. We've put so much work into this already. It's been about 2 weeks of building just to get to this point. If it breaks now, we're in trouble. Okay. Okay. Well, it feels like it's getting some lift, which is to be expected. Oh! Whoa! Yes! That was about 2/10 of a second of flight.
Although we were seeing promising signs from the wing, there seemed to be a huge amount of flex in the tail, stemming from those sketchy 3D printed joints from earlier on.
Whoa! Ah! Oh no! Oh no! Oh god! Oh, ah! Oh no! Oh no! Oh god! Ah! Well, it did something.
The plane had wanted to fly away, but before I was ready for it, the tail flexing had pitched the giant glider up towards the sky and then suddenly nosed down at the ground. Going back to the drawing board, I made some stronger connectors for the 2 tail surfaces from some brass. The 2 halves of the V-tail were now fitted together, and this more solid part could now be rested upon a cradle and fixed in place with rubber bands, just like the main wing. Unfortunately though, this tail still turned out to be somewhat on the wobbly side. Perhaps the entire fuselage would need a total rethink.
Oh well, let's just hope.
For now though, we wanted to push ahead and wire everything up for the first radio controlled proper test flight. After checking everything, now we could finally go for the first glide.
Okay, you make sure that wing doesn't come up. Okay, ready?
Yep, when you're...
Yep, okay, and then 3, 2, 1. Release. Well, we thought that might happen.
The wing's intact.
Yep, the wing's okay, I think. Oh man, it's just not strong enough. We need to make it stronger. Sacrifice the weight, make it stronger. That was, I fear, quite inevitable.
I now knew what we needed to do to get this thing to fly, and where the weak link had been. With a few hours of good weather left on this day, I decided to build a giant box-style fuselage from foam board. These box sections were joined together and fitted with a huge traditional style tail. The entire aircraft was now totally different, but crucially far more rigid.
That doesn't actually look that bad.
Despite later being described by Emma as looking like a child's drawing of a plane, I thought we'd made a big improvement. At 9:30 p.m, after rebuilding this plane twice already, I had one more opportunity to get it flying and another opportunity for total failure. With the light fading, would I finally taste success, or would this be the end of the project?
Yes! Oh yes, finally! Oh, finally. What a relief. Oh, that flew spot on. No problems whatsoever.
The next day dawned with low winds and clear skies, so Emma and I took the opportunity to get some more practice in with learning to fly our new gigantic model glider. Although the plane was now flying beautifully, I discovered quite a key issue with being unable to launch the plane consistently.
No!
I had to keep two hands on the aircraft while running forwards to stop the entire thing toppling before we got to the right airspeed. This was really frustrating as I couldn't use the controls at the same time, which felt super sketchy. Thankfully, Emma stepped in and we soon devised a reliable system of safely raising the plane up together, Emma on the fuselage and me on the wing, with one hand on the controller.
Yeah. Throw!
We needed to get this nailed, as the next step of the project would be to build in the remote rocket ignition systems, which would provide ample opportunity for things to go a bit wrong.
Haha, nice. Yeah, we're getting pretty good at it. You're taller than me, I think, in terms of your reach. I couldn't reach it.
Now, to fit the rockets to the glider, we would need to build a heavy-duty rocket mount. This would need to be extremely strong to deal with the thrust of the large motor we wanted to eventually use. So I decided to recycle an old carbon fibre model rocket I had lying around, originally designed to be flown on the same size of engine. This would be a super strong mount for the engine, and only need slight modifications to repurpose it for its new role as part of the world's largest RC rocket plane. With the subassembly complete, I could now securely glue this to the nose of the aircraft. The plan had always been to place the rocket engine over the nose, as had been the case on the prototype. This would be advantageous in keeping it as far away from the launch team as possible for safety reasons. Now, if I was to do this differently, I could have used PCBWay, who are actually sponsoring this video, to make a motor mount for me using their metal 3D printing service. And all I would have had to have done is CAD something up on my computer and then drop it onto their website, where they would then manufacture it and then send it to me in a matter of a week or so. I've already made lots of different parts for all sorts of projects, and have recently got them to print this jet exhaust tube for one of my gas turbines. I've also had friends use their PCB prototyping services, and this has been super helpful for their electronics projects. So yes, definitely check out PCBWay's online configurator. There's a link down there, and it could be very useful for your own projects. I very much recommend them. All right, back to the aeroplane. With everything fitted, the plane was now nearly complete, and it was time to look at the weather for the next window of opportunity for a test flight. The lowest winds would be in the evening, so we worked throughout the day to finish the plane for a sunset test, and this would be our first rocket-powered launch, which would prove that this record-breaking plane could actually fly under power.
Right, well, we've finally got everything ready for the first test flight with the rocket engines. We've put tin foil all over the tail so that it doesn't get scorched off. We've We've also got tinfoil on the wings. Emma's been doing all of the igniters and all the soldering and doing all of the final wiring on the systems inside the aircraft. And also she's been doing the final job, which is to write my Patreon names on the tail. So thanks very much to all of my Patreons for, supporting ProjectAir and helping us to build crazy things like this. I'm very nervous. This has taken so long. This is the biggest aeroplane I've ever built. And if it all goes wrong, then yeah, that's not going to look very good, is it? That's what all of this is about though. It's about pushing the boundaries and to challenge yourself in an engineering way and meet the goals that you set out at the beginning of the project.
You need to remember to drive at 5 miles an hour.
So we are going to do 2 test flights. The first one's going to be the smaller rocket size that we've chosen for this aircraft, and then the second rocket engine is the massive one, which is going to be quite spectacular hopefully. So if the first one works, then we'll progress.
With the rocket engine installed, now it was go time. The atmosphere was tense. This was a highly experimental glider that had never flown under the loads it was about to experience. I ran through my checklist and prepared the plane for flight.
Plugging igniter in. Yeah, we're going to aim for sort of those trees over there.
Yeah.
Yep, okay. Okay, and going up. You got it. Yeah, good point of contact.
Even though this was the smaller of the 2 rocket motors, we were a bit worried about our flexible wing, thinking it might flutter under acceleration, destroying the plane in seconds. But now all we could do was launch it and see what happened.
Okay, and then we're going to start walking forwards. Okay. Yeah, keep going, keep going, keep going, keep going, keep going, keep going, keep going. Now! Yes! Okay, coming down, going to try and land it in the other field. Establishing glide slope. That worked so well! That went better than I thought it was going to, actually. Oh my goodness, did you see that?
Yeah, that sounded so dramatic.
That amazing! Oh, that's crazy! Look, we landed it over there. So we've gone about, how many meters away is that? About 188 meters away. Yeah, what a spectacular flight.
The plane had flown really well, but that was just the first flight, with the small engine size. Now it was time to push to the limit, and see if this plane would survive the enormous thrust of the second engine, which had far more power. Would the plane now be able to climb and circle, just like the smaller JetX gliders that inspired this project?
I'm gonna feel this in my shoulders tomorrow. Okay, safe, right, get centre of gravity. Okay.
Yeah, ready?
Okay, ready. Walk forward. Run, 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 run. Yes. Okay, bring it around. Bring it around, coming in for a landing. Oh!
Let's go!
Yes! Wow! That was brilliant! That was absolutely fantastic. I can't actually believe that worked. I'm actually lost for words.
Miraculously, the wing had survived, after experiencing a dangerous amount of flutter during acceleration. So we'd done it. We'd accomplished the goal set out at the beginning of the project, to build and successfully fly the largest model rocket plane the history of model aviation has ever seen. Originally inspired by tiny rocket gliders designed many decades ago, we'd pushed this concept to the limit of what's possible with today's tools and materials, and built an aircraft that, after many ups and downs and a few late nights, finally achieved something that was really quite impressive. With this video, I hope that you enjoyed it and that you learned something even. If you did, then make sure to subscribe to the ProjectAir YouTube channel so that you can help ProjectAir grow and help my channel reach more people and all of that good stuff. And also, you can get notified of future uploads. It's free and it would really be appreciated. So yes, thanks very much for subscribing. Click that button. Here is another video for you to check out while I build the next project. Check this one out next and I will see you there. Yeah. Cheerio. See you on the next one. Bye for now.